automation. I'm Christopher, I work at Shopify. Okay. So basically, now's when you're going to learn that the kind of casual demeanor I had for the first presentation when I didn't know what I was talking about is also the one I have on the presentation I wrote myself. So you'll be okay with that, I think. So first I'm going to talk about some things that are only vaguely true to paint a picture that's mostly correct. So in the early days of 10 years ago, not even, you have your servers over here, and you're running programs on them. These little process diagrams I found. I decided those would be programs, so that was kind of cool. So you're running processes on your servers here and your laptop, and I mean the laptops didn't quite look like that. But, and then when you wanted to administer them, you'd SSH into your servers and you'd do something with the processes, right? I'm not 100% sure about why I got this direction at all, but it's fine. So then later, that became tedious as hell. And so some people maybe moved in this direction. So rather than SSHing in and provisioning all the servers yourselves, you might have some tool that does that kind of management for you. Chef or Puppet or Ansible, which is a little different, but still pretty close. Others, many solutions. So in this case, you would interact up with your kind of management server, and you would do things like, I would like these kinds of servers to have these kinds of packages or whatever. Then that would flow down to the actual machines who would then run all of the management. But in general, you would still interact with the individual boxes by going over to them and then dealing with the programs that are running on them. If you want to, I don't know, I mean, again, you shouldn't add a package, but like you could if there was a disaster or something. So I'm not, by the way, there's no judgment here. These are all perfectly acceptable answers. Kubernetes works almost exactly like this, but I'm pretending it does it for sake of argument. So in this case, Kubernetes, one of the things that Kubernetes does is that if you are looking to see what the state of a particular process or something is, you don't go out to the machine that it's running on and ask it what the state is. You talk to the Kubernetes server, and technically the workloads are also running on the nodes down here, but you don't go to the nodes to figure out what's running. If you want to restart a service, unless something's really on fire, you don't go to the nodes to restart the service. You tell Kubernetes API at the top here, I would like the service to restart, and then it does wherever it happens to be running. And so that's kind of it was also, again, I made a very simplified picture of those last three slides. There's many nuances in between, but this is what we're talking about today. Is that the Kubernetes API kind of has the state of everything inside of it, and the individual nodes that it runs on are kind of abstracted away most of the time. And so you might have like a person who goes in and asks the API, hey, what's the state of this application or something? They get back some answer, they think about it, and then they make some changes based on what they've seen. So what you can do here is you can take the laptop and turn it into a bigger program. And now in this case, you've got one source of truth for all of your programs or whatever, but rather than a human going through it, querying for current state, making some decisions, and then telling the API some new state, instead you can have a process that does this. And it asks the API things, it makes decisions, and it pushes new things to the API or changes or whatever. That's the high level of what I'm going to be talking about today. In the examples I'm going to be running, I'm going to be running the scripts off my laptop. This is going to be it's a little bit technical because I wrote code. But you can kind of just blur your eyes through it. Hopefully it'll be, I wrote it in like a day, but it's okay. But in a normal way that you're running things, what you would actually normally do is you would run the automation code inside Kubernetes itself. I didn't make a slide for this because it would have been really confusing, but it's kind of up there and it does a little loop-de-loop. But in which case you can actually basically package business logic and stuff into your cluster because it's running inside the cluster itself. It's kind of self-managing. You can use it to do some workloads and stuff. So basically, I've got 4 examples of different kinds of automation that you might want to do. There are other examples that I'm going to touch on some of them at the end, and some of them I'm not even going to talk about, but hopefully it'll be enough to kind of get the brain flowing. And now I have to figure out how to use this program. This is a simple one. Okay, pull that, pull this. Good enough. Okay, what do I want to do here? Okay, so all of my scripts are going to be in Ruby. None of these scripts that I'm showing you are actually scripts that we run at Shopify. Some of them are kind of inspired by scripts that we run at Shopify, but I've got a script down. So all of these kinds of automation are automations that we do here, but not these particular scripts. So don't worry about anything like that. So kind of, first example, kind of what am I talking about here? We're talking about automation. Can people read that? Is that big enough? Should I make it bigger?
Bigger.
Bigger, bigger. Is it getting bigger? Yeah? Can you read that? Great. Okay. So super simple. Well, I mean, pretty simple. If you don't read Ruby, just kind of, again, I'll walk through it. Now I can use the cursor that's on the screen. Look at that. Okay, so I'm going to start off here by fetching a Kubernetes client. I happen to have made my own, but that's okay. And basically all I do here is I say, watch the namespaces. This is essentially equivalent to running, if you've ever done it inside kube control, if you do like kubeget, what would I can show quickly? Services? Oh no, let's just do namespaces. That's why I wrote this one. So if I do kubeget namespaces, it will tell me all of them. If I throw a W on here, it'll do a watch. So now if I do kube create namespace down here, I never really realized how hard this might be to follow from just jumping around. But alright, so down here at the bottom, if I say stuff, you'll notice that it immediately pops up. Hey, here's this new namespace. If I cube delete namespace stuff, say it's terminating, and then it's gone. It doesn't actually tell me about that one, but it's like, what would it show me, right? But, so that's, okay, now it's on. So this is the thing that the kube control, this kube command up here is just a wrapper I wrote that goes around kube control. It's basically exactly the same. For all intents and purposes I'm going to be talking about today, it's identical, so ignore that. Okay, so this is a feature that the Kubernetes command line tools offer you, and the libraries, almost all of them have it too. So back over here in Ruby land, I'm just issuing watch namespaces, which is first going to, similar to this one up here, it's going to immediately give me all of them as though they were just added for the first time, but then it's going to keep running, and every time a new one comes out, it's going to pass that in. And I'm in the wrong terminal, and I'm hitting the wrong buttons. Okay, so basically all I do here is I say, for this particular integration, I say, if this isn't a new namespace that was added, then I don't care. I'm not handling updates because it's not important to what I'm doing, and I'm not handling deletes because that'll get handled for me. I'm going to figure out what namespace it was that just got added, and basically I'm going to produce a config map called sample config. I'm going to fetch it, and if it's already there, then I'm just going to log it out because I don't actually care. Otherwise, if it was not found, then I'm going to make a new config map, and I'm going to put this test data into my config map, and I'm going to create it. And that's all I do, and then I go around the loop again. So this is like a really simple, what's it called? Automation. We'll go with that. That allows me to basically just dump some static information to every namespace. So if I go and say Ruby example 1, normal, so it's running down there. So those are all of my existing ones. Some of them had already had it in it. So if I say kubeget config map, or even kube describe config map, I will see that I've got this key test value data that's provided in my namespace. And then if I do kube create namespace stuff again. And then I do cube get config nav namespace stuff. Sample config is already in my main. That's practically what this one does. The reason why I might want to do this in this particular example is maybe there's some bit of kind of global state that I want all of my pods to be able to pull in. Maybe they've got some, so maybe they want to know what location they're in, or, oh shit, it's not on that cable. Maybe they want to know what cluster they're in, or they want to know what region they're in, or which Kafka brokers to talk to, or whatever it is that I'm interested in. But basically, this will just make sure that if there's a namespace, it has this information in it. And currently what I'm doing over here is I'm doing nothing if it's already there. That's just kind of for sake of convenience. What I would probably want to do in general is I would want to update it. So then I can make my update in this one script, and it will just go out and update my config maps across all of my namespaces to be the most up-to-date information. So this is relatively simple, but it kind of gets the idea across. It's going out to the API server, fetching back all the namespaces, and then producing secrets based on what it saw. So yeah, so that's basically this first one. And then the reason I don't have to handle deletes is obviously because the config maps live in the cluster or in the namespace, and I delete the namespace, and it all gets back to my form, which is great. Namespace. Okay, so in production, we have a couple scripts that kind of follow this simple model of looking at the resources that are already there and doing something. So one of them we have is, so we use the name buddies for all of them because the word operators didn't exist yet. So we have one called Secret Buddy, which basically does a very similar version of this. It decrypts secrets into each namespace based on some stuff that it sees there. And make sure that everyone has the latest keys and all that kind of stuff. We have one that handles Kafka, like I had mentioned. So basically, it makes sure that every namespace has access to some seed list of Kafka brokers to connect to that differ between clusters for regional reasons. But again, we can keep all that logic in one place. Every one of our pods doesn't have to re-implement service discovery, etc. We can basically just roll a config map that's ever-changing out to everything. And one of the other reasons for writing automation like this, or the ones that come up later, is that it also allows different teams to not really interact as much as they might need to. So for example, on the Kafka team, rather than having every team have to figure out how to do service discovery for Kafka or whatever, the Kafka team can be the one that produces the logic that just dumps names of the appropriate type into all of the pods. Everyone else just can trust it will be there. When they run, there will be this config map that has the data that they're interested in, that they can pull into environment variables or mount as files, whatever one wants to do with config maps, just in case you've never seen config maps before. I have an example of that, but it's like 2 for now. So different teams can kind of be in charge of that. So for example, with us, the team that decrypts secrets into all of the different namespaces is a different team than the team that does service discovery on Kafka, but they both operate in a similar way. And all of the downstream users don't care who's doing anything, because it's just the secrets are there when they need them. We also have one called Event Buddy. So interesting kind of point. Actually, can I put it? I can't really show it right now. But whenever you do like describe, do I have pods or search style or whatever? Whenever you do like a describe, you get like this list of events at the bottom. I don't know if people have seen that. So those events are first-class resources in Kubernetes. You can just do like cube get events, and there aren't any right now because this is a relatively fresh cluster. But so one of the things we found is that they were kind of maddeningly transient. They would just be gone every time they actually wanted to find out what had happened. So what Event Buddy does is basically it just watches all of the events and it throws them all into a database somewhere so that we can do like lookups on them and stuff. It's not a database, it's a search, but still. So that one, again, we haven't changed what an event means. We're just watching the events that are already there, and then we're offloading them into a different service. So that's that one. Questions at this point? Yeah.
So how do you actually deploy that?
Yeah. So basically, right now, I probably should have done that part. So basically, right now, this is Ruby script. So what we would do is we would use the normal, we'd run Ruby at Shopify. All of our actual automation is in Go, but we have a pipeline for that as well. It's but yeah, so basically you build a container containing this script in it and whatever dependencies, and we just do like, we would build a Kubernetes manifest, their deployment of size 1 in practice. And we run it, and then anything that's running in Kubernetes can find the Kubernetes API at kubernetes.default. It's kind of a default service that exists there. Kubernetes services. So that right there is an in-cluster discoverable endpoint for the API. So you can point your client, which like my client is configured to look at Minikube, but a lot of the clients you get have some. Because it's a standardized way of talking in cluster, they have some built in like, oh, are you in cluster? If so, just use Kubernetes.default, it'll get me there. And also, if you mount service accounts, which like if you set service accounts to be mountable in your pod spec, then it will also give you credentials that are allowed to talk to the Kubernetes API at particular mount points that are well known. And so. And if you've got any sort of RBAC or anything like that, then you would have to configure that like the service account has the ability to list secrets and create, list namespaces and create and get secrets or whatever for access control stuff. But besides all those complicated words, practically you push it up, it discovers that it's in Kubernetes, it grabs the certs off disk that it's been provided, it grabs the DNS name that's been provided to it, and it can just talk to the API from inside Kubernetes. So Kubernetes is built to operate in that way, and so then you just deploy it like any normal app, and it just runs on the inside, basically. Yeah. Other thoughts before I move on? Cool. So the next one, maybe this one will go faster than I thought. We'll see. Is annotated. So sometimes you might be in a situation where you want to do the last one, and that works pretty good, but sometimes you want accessory information, right? You don't just want the namespace, you also want something about it. So essentially you want arguments to your automation. So that's this one. So what we're doing here is I'm mocking up DNS because it's easy. It doesn't actually do DNS, but it pretends to. So here I've got this zone, which is an empty hash. It's a debugging thing that just dumps out the zone so far. And so in this case, I'm watching services. So tell me all of the services and every new one that comes up. And every time I see one, I'm going to reach into the events, objects, metadata, annotations, example.com/DNS. So every resource has an annotation in its metadata, which is just random data you can throw at it, basically. So one of the things you can do with that is to get information into other bits of automation. So that's kind of what I'm doing here. There are probably other ways to do it, but this is the one that we use. So in this case, I've marked up individual services to say this is the DNS I want associated with this service. Then it grabs the cluster IP. And then basically it says if this service was modified or added, then I want to see does it have the DNS, my special DNS annotation, and if so, does it have a cluster IP? And if both of those are true, then I'm going to jam that DNS name and that IP into my thing and dump it out. And then if that service got deleted, then I'm going to want to delete the DNS entry that it had. That's basically what this one is. Where is this thing? So this time I'm going to run. Oh, this is an awkward position. Okay, so I'm going to run this over here. And then, fingers. It's not a very ergonomic example. Okay. So then I'm going to want to do E2. So for right now, it hasn't done anything because I only have that one service and it wasn't marked up in a special way. But if I go over here to E2's service 1, okay, let's service 2. So this is a normal Kubernetes service, and I haven't done anything much to it, except I've added this special annotation here to the metadata that says I want this to be special service, so example.com. Other than that, it's a normal service. It's got selectors, reports, and all that. So if I do create Greek, it's a Greek service. Okay. Service 2, there we go. So you'll see my annotation down here. I got my service, I got the ID, I jam it in there. If I go through and I produce service 1, then now I have both of them. If I delete, let's do service 2, then I'm going to go service 1, and I delete both of them. All right, yay! So this is a simple way to basically take an existing Kubernetes resource that describes something that you're interested in, but add a little bit of your own business logic on top of it. This is a normal service. It's managed through the normal Kubernetes pipelines, but we have this special thing at our company that we want to do with it, so we can just add a little bit of information in there. And then other than that, Kubernetes does what it always does with that service. But we can write this extra bit of automation over here to watch it and pull out particular fields that we're interested in and then perform automation based on that. So we use this kind of automation for almost exactly this case. It's a lot more complicated code-wise. We call it name buddy. So basically here where I'm updating my zone array, in this case would actually call it to a real DNS service and do the API stuff to actually produce these DNS entries. We also have things, so we watch, it watches services and pods and ingresses to figure out all these IPs and do the actual hookups and stuff. But what this gives us is basically, again, it's kind of a self-serve model for our downstream users. Basically, they can just have a YAML file of their own where they have an ingress, and they can just say, I want this name, and then they click deploy. And that's it. They don't have to talk to anyone to figure out how to set the zone file or whatever it is. They can click deploy, and then the automation written by the DNS team does all the actual parts to make that work. And then obviously, it also doesn't touch internal IPs as much. I mean, it can, but we also use it for external IPs a lot more often for obvious reasons. But yeah, so that's a real one that exists. Other ones, I don't remember which other things use annotations, but that's the one that kind of stands out to me because I wrote part of it. But yeah, questions about that before I move on?
So, 2 examples. It's really the power of the watch functionality more than the API.
The Kubernetes API? Yeah, so the watch API is great. I mean, obviously you can pull things anytime you can do a get, but the watch is nice, and what's also really nice, like I said before, that other tools give you, but what I like about this is that everything lives in the one API. So if I'm watching pods, I get all the pods from all the namespaces, no matter what nodes they're running on. They all come through this one API call down to my automation that's running among them somewhere. But it doesn't have to be on the bots. It doesn't have to do. It can basically. The thing that's also kind of nice about it is about all of these automations, in my opinion, is you can basically pretend that Kubernetes always had these features. So by default, Kubernetes doesn't update external DNS when you set your services or something like that. But with this automation now, it does. For the extent of everyone who didn't write the automation, they gave it a special key up in a thing, and now it just magically works. Or like in the previous one, it might be nice if namespaces had some sort of default set of things that come with every namespace ever created. And now they kind of do, because I've got all these tools that are just watching for new namespaces and populating them as soon as they spring up. You can do all of these things with other systems, but I find it actually I find it particularly nice and or at least interesting in the way that Kubernetes does these things. It feels kind of first class, which I like. Other things before I move on? Yeah.
Why are you doing it in a service instead of
In what?
universe?
Oh, because I wrote this in 2 seconds. Like I said, our actual automation does use ingresses and services and even pods. Those are for internal purposes, but still. So this, because it was easier to get MainCube to create services than ingresses, is why this particular script watches services. But the real life one that we deploy does watch ingresses. Yeah. Okay. So both of these things are two ways of kind of using or reusing Kubernetes' existing resources, the ones that it gives you, like namespaces and services, pods, etc. But sometimes you have an external integration that either, for a couple different things. One, maybe this external integration doesn't really belong to any particular resource. Like maybe it's an API key, which happens to be an example I've got here, that it's not really attached to any pod. You're not going to watch pods for this necessarily, and you could, but in this example I don't. Maybe it actually exists kind of between pods or whatever it is, right? This is a thing that is shared, like maybe like a database table or something like that, that you just kind of want to exist in general, or you want it to exist before you deploy your workloads. You don't want it to be like a hanger on this thing. It feels like its own thing. So in those cases, that's when the custom resource definitions can be used. So custom resource definitions, I think were stable in 1.9 or at least beta. Before that, there was a thing called third-party resources, or TPRs, custom resource definitions, or CRDs, and they replaced them. And now, actually, I think it was 1.8, and then they became required in 1.9. I don't quite remember. They've had a history together. Custom resource definitions are the current thing, and then every version they get some new abilities. So I'm going to talk about that real quick. So basically, a custom resource definition is itself a resource. So in this case, this is written in Ruby rather than YAML, but you can see, other than that, it's the same kind of translation. So these are from the API extensions API in Kubernetes. They are called custom resource definitions. They have a name. So this one is tokens.example.com. So they are tokens. You can see in the specification here that they come from the example.com API group, version 1. And they are namespace, which means that they exist within a namespace. So when I create a token, it belongs in a particular namespace, whereas other systems might not. Like, for example, persistent volumes don't exist in a namespace. Persistent volume claims exist in a namespace. Persistent volumes are just globally true. So you can make custom resource definitions that are global or namespace. This one is namespace. Then this is basically just to set up the API. You can call them tokens, or a single token is a token. This is kind of an obvious case. I mean, third-party resources it would kind of guess, but then you get examples like queries, and it's like queries, and English sucks. So they've got two fields here. The API kind is token, and then on the command line I can also call it T or top, because I made that up and I just wanted to show off the feature. So I can basically do Kubernetes get, let me go to this one. Move it up to this one. So I can do Kubernetes get T, and it says, aha, there's a token. And I'm going to delete that because I'm going to create it instead. Oops. Token, first token. So pretend you didn't see that. But yeah, basically, it's now, this thing exists, and within the Kubernetes API, the same way as any they both exist in Kubernetes. And now this is kind of like a real extension where Kubernetes will hold on to these things when I create them. It'll keep track of what namespace they're in. It'll allow me to list them and update them, watch them, all those kinds of things I would do with any of the built-in resources, but they're mine. Now, kind of importantly with these, with CRDs, they don't actually mean anything. Like Kubernetes doesn't know what a token is. It just knows that there is one, and it will return what it's given when you ask for it again later. That's all it does. It basically just holds on to it like a database, basically. So the part that's actually kind of the extension is that you can use these in automation that's very similar to the ones that I showed you before. So for example, in this integration, the files get a little longer. So here, basically, all I'm doing with this line is I'm saying, make sure that this token's custom resource definition is on the API, and if it's not, put it there. That's just kind of almost boilerplate. Then in this particular example, I'm making this tokens hash thingamabob that is kind of mocking up like an API key server, because I don't want to actually do calls out, because it's an example for a meetup. So then all I do here is I'm saying watch the tokens. And that's kind of it. But instead of services which are built in or pods which are built in, I can just say watch tokens in Kubernetes. And all right, I know what tokens are. I know how to watch things that I have. So I'll just tell you anytime anyone publishes one or makes changes to it. And then we react to that. So basically we say anytime one is added or modified, I'm going to add it into my set of tokens, and I'm going to dump out the key that I found there for debugging purposes. And then back to our old tricks, we're going to make a secret in this namespace. The same namespace is the one that the token was published in, because it's a namespace resource. Normal secret stuff, it's opaque, and it's got the key and the permissions. And then I'm going to create it, and if it already exists, then I'm going to update it to keep it up to date. That's basically what this one's doing. And then anytime a token is deleted, I want to delete it from my token set and then delete the secret out of the namespace because it's not accurate anymore. So that's the extent of my automation here. So in this case, I'm going to run it like Ruby E3 integration. So it's running. Then I'm going to create. Oh, right, I should actually look at the token. Token 1. So this is my YAML. It looks very similar to anything that you would see from one of the built-ins. This is a token that comes from the example.com v1 API. It's called first token. And then these fields I just made up because I can do whatever I want in this thing I just made up. So in this case, I've got read, write, execute permissions and some sort of descriptors. So if I, where are my fingers? So if I create this thing the same way that I create any other Kubernetes resource, I'll see this kickoff down here. And in fact, if I create a, just for example purposes, I've got this deployment here. So if I get my, okay. My deployment here, deploy. So this is just a deployment that I keyed up. It's a normal unmagic deployment. Notice I've got this here. It's kind of a while loop that just prints out all of my secrets. But so I just kind of wanted to show how you might use this kind of secret if you haven't seen it before. So basically I'm saying this token, first token, secret that gets created when I publish this token resource, I'm mounting it as a volume. And I'm mounting it inside my container at the particular path. So the inside container can see the secrets of the code. So if I go here and you get pods, then I can look at my logs and I can see the secret that I created, which is the same one that I've got down here, the same permissions. And then if I run this again, go over here, if I do cube, edit, token, first token. So Oh, what the? God damn it. So I can see that I got pinged here, and then up in my pod that's now with the secret on my next update or so, I should see that I've got the same key, but I've got different permissions. That's kind of what I'm demoing on here. If it works. Anyway, let's just talk as though it worked. Secrets do take more than a second to propagate. Whatever. Who cares? So this kind of thing we do in a couple places at Shopify. This kind of like custom resource that represents, again, some object that's different from just different from one of the ones that's built in, but we want to kind of pretend it's built in. And treat it as a separate entity, either again spanning between pods or existing before pods. Because, for example, this particular, that's really bothering me. This particular integration, I want it to exist. I'm just going to stop running it. It did work in demo, but anyway, should exist before any pods that need the secret needed. So I would deploy my token first. I would wait for it to load, and then I would kind of run the other workloads and stuff on top of that. And then from then on, it'll kind of keep it up to date. But it's really a different thing. So we run it a version of this that's very similar, where again we have some API key server thing that it'll go out and it'll fetch API keys for all of the people that request access to it, and it'll authenticate with their name and everything like that. And then to provide it, we have one that provisions databases. So people can basically request, I would like a database of roughly this size with this name, and we'll go provision it somewhere on one of our DB servers, and then we'll give you a secret that has like a connection, like username, password, hostname information, so that you can again pull it into your workloads and connect to your databases like that. Written by the data stores team. We have one that is again another Kafka integration. So we run Kafka clusters inside Kubernetes at part of the company. And so one of the things that we do is we explicitly manage the list of topics that is in our Kafka brokers. So in that case, we actually have a topics resource where we say these are the topics I would like you to have, and then we have an integration that goes through and finds those and then publishes them to the Kafka servers in here. So again, people can deploy topics and then it'll show up magically inside the servers. We have one for again bug snag, crash log keys. We have one for provisioning either Google storage buckets or Amazon EC2 buckets or S3 buckets. So again, yeah.
So when you change a config map or a secret, you need to restart the flood, right? Because it's with a new...
You don't have to if you mount it. If you put it in an environment variable, you do. You shouldn't have to if you mount it on disk, which is part of what I was demoing, but obviously that didn't go so good. But trust me, it worked like half an hour ago. Now, most services expect to read the file off disk once at initialization time and then never again. They're usually not watching a file for changes, but technically the kubelet does make the changes when it notices new values. So these are all like third-party integrations where we feel like there's some resource that isn't represented by Kubernetes, and probably shouldn't be. There's no reason for Kubernetes to have an S3 bucket resource that it manages, but we do. And so we can have different teams that work on all of these different integrations, and the downstream people can just say, I would like a bucket, I would like it to be this big, and I would like it to be an east. And then some integration somewhere goes and makes sure that that's a thing, and then puts the secrets or whatever it needs somewhere that the workloads can use them. So that's a pretty popular one. And then the last demo I'm going to show. Move this really carefully. Oh no, it says this. All right. So the last last thing is sometimes it's more than just an external integration that we want to represent inside Kubernetes, but it's actually like a thing that we don't want to run. So this one is a custom controller. So this is not a great controller. It's a little bit, what's the word? Contrived. But that's okay because it's an example I wanted to fit on the screen. So what this one is same kind of CRD here. It's got all the same fields. This one is called I call it a cluster because it's super generic. This is an example. So but you can figure this being Elasticsearch or Kafka or Zookeeper or Cassandra or Redis sometimes. Any sort of clustered thing. So this is custom resource definition. Yeah, it's a cluster. And so what this controller does is, I'm watching two things in this case, and I had to hack around Ruby a little bit. Because again, I was on a tight time frame to get this out in time to show you people. So basically here I'm watching clusters, which I did as custom resources I just made, and every time a cluster comes in, I'm doing this relatively simple bit of integration here. So basically what I'm doing is I'm going and fetching information out of it. I've arbitrarily, I should show you what a cluster looks like. E4, cluster, what the hell? So this is my simple cluster that I've made. So it's a clustered application. It's called test1. And I've made up some fields here. I say there's 9 cores and we're on version 1, whatever the hell that means. And then so over here what I'm doing is I'm saying, again, trying to make my point, but I'm saying that, okay, replicas is abstracted away from the user of these cluster things. They ask for cores, and for some reason there's 3 cores per replica. So basically, replicas is just going to be whatever the number of cores is divided by 3, and then seal it. Just us. And then I'm going to build a deployment, like a deployment, Kubernetes deployment, based on this name and namespace. I'm going to dump it into their namespace. Some people will write an integration that dumps into a special namespace that the users don't have access to. Both of those are options for different reasons, kind of. So then I'm going to set some annotations here, like the number of replicas and the version that I want. I'm going to show you why I do that in a sec. And then I'm going to produce that deployment. And if the deployment did not already exist, I'm going to make a new one, set the replicas in the version, set the replicas again. This is a helper I wrote for myself that basically just fetches the real version environment variable out of my deployment and sets that to a thing, and then sets the API version environment variable to the same thing. It all sounds very complicated. It's not that bad. And if it's deleted, I just delete the deployment, right? You got rid of the cluster, your deployment goes away. That's kind of the rule here. Just for completeness, I should show you this part that I'm hiding. So this is just a normal deployment, but it's done in Ruby instead of YAML. So there's nothing really magical here. I'm basically just filling in some values in a template. But it's big and long because there's a bunch of stuff that it does. I've got like some init containers down here. I've got some normal containers with these real version and API version fields. All my container actually does is just sleep because I don't actually think do anything, but pretend it's Elasticsearch or something. Yeah, so basically this is just building the full Kubernetes deployment object from my few fields of interest. Okay, so that's kind of that. I think that's enough that I can run it for a sec just to get something out of it. Oh, before I do that, let me make sure we'll get clusters. Great, okay. What is this? Controller. So I run it, nothing happens. Then I create my cluster the same way as you've become accustomed to. And in this case, it actually goes out and produces a deployment. Ignore the rest of the logging. Don't look behind the curtain. So if I go and I get a deployment, I can see that I have a cluster test1 deployment that's been spun up. I've got some pods. Why is test secret? What the hell is that? Oh, that's the thing. That's my logging that I don't want to look at. Let me just get rid of that. That's good. Screw it. Okay, keep good. We're going to ignore it again. Okay, and if I get pods, you can see that I've got 3 of these plus tester pods running. Okay, so that's kind of part 1. I've taken my cluster in and I've produced a deployment based on a few particular fields. So now what I'm going to do is part 2. Let me just kill that one. Okay. So part 2 down here is I'm also watching deployments. Every time there's a change to deployment, I jam everything. And so what I do here is, if the deployment's been deleted, I don't care. I don't have any automation special needs that I need to do at this point. Other than that, I'm going to pull out a couple of fields. So this is the status of the deployment, how many replicas are up to date. This is how many do I want in general. This is how many of them are ready. So this is, I'm going to use this to try and figure out what state my deployment is in right now, because I'm writing a controller that manages whatever this cluster represents. Currently it's BusyBox, but it could be applying in Elasticsearch. They're really important. And then I also pull out my special annotation, which is like, how many replicas do I want the deployment to be, because I'm making work for myself to make the demo more impressive. I figure out what version I want it to be, and I figure out the real version it's at based on the environment variable, and the API version it's at based on the environment variable. So then I basically just have this kind of cascading logic where I say, if the updated replicas isn't the same as the replicas, and the ready replicas isn't the same as the replicas, then the cluster's doing something. The deployment is in some sort of operation, just don't touch it. Otherwise, if the replicas is different from the desired number of replicas I want, then I'm going to set the desired number of replicas. So this is basically saying, don't scale my cluster while it's busy doing something else, right? Wait for it to be done, whatever it's doing, then set my number of replicas for some reason. Then, if the number of replicas is right and my real version doesn't match the version that I want based on my annotation I've stored, then change that, and then it'll go roll out. And then finally, once that's all rolled out, if my API version is different than my desired version, then I roll that out. So that's kind of the made-up contrived logic I built in here to show like a complex operation. And then I just want stuff. But anyway, so if I run this again, and I do edit cluster, what do I call it? Cluster first. Oh no, yeah, test one, thank you. So I'm going to go in here and I'm going to change the number of cores to be like 15 and the version to be 3. You get pods, W, just so I can see what's going on. Okay, so hopefully that's still running. Okay, so this is going to set the deployment. And so this first it's going to, you know what, this is actually kind of a shitty way of watching it. Watch. I'm going to miss all the important stuff. Okay, so first this is going to scale up. And so you can see that the number of replicas was wrong and that it's doing nothing. Now once it's scaled up, it's going to change real version, and it's going to go through and do a rollout, where it rolls out the real version to be the version that it wants. That's going to take at least a couple of seconds. Oh, also notice that I set the number of replicas to be like 15, and then it did 15 divided by 3, and decided that 5 was the number of replicas it wanted because I abstracted that away from the user. So it's still waiting for that to roll out. So while that's happening, I'll start talking about kind of use cases here. So this is kind of one of the more complicated kinds of extension that you can build. But in this case, you've basically built a real thing that works the same way as a lot of like deployments or replica sets or stateful sets or whatever it is. You've built some new thing that didn't exist in Kubernetes, but now it does. The reasons for doing this is basically the same as the reasons for the other ones. It allows you to have different teams that do different things, and your downstream users can just say, I would like an Elasticsearch, please. I keep using that one because this is a deployment we actually have, again, a different code, and it's much more complicated. But like, we do this at Shopify. We have a search buddy, and every time it sees an Elasticsearch reference, which has like configuration variables and the approximate size and whatever else it does, it will go through and produce stateful sets for the different kinds of nodes that you have in an Elasticsearch cluster. It points them all at each other and all that kind of stuff. But the user doesn't actually see any of that, but the app developer. They just said, I would like a search cluster. I want it to be roughly this big. I want it to be using Elasticsearch 6. And I want, yeah, that's basically it. And then we go and produce a self-managing automated cluster. So that's part of the reason. Oh, good. So the real version rollout is finished, and now it started rolling out the API version change. So they contrivably decided I wanted those to be staged for some reason. So we have similar things in Elasticsearch, in the Elasticsearch button that we have, because basically when you update the the CPU requirements of your Elasticsearch cluster, you say, I want it to be heavy instead of light or whatever. It goes through and it populates all those fields, it rolls them out gracefully so that they, it coordinates between different stateful sets that it spins up in the back end, like some for data and some for like handling web requests and stuff, to make sure that they all don't go down at the same time and stuff like that. So in the end, it's all kind of built around the same primitives that you could use. There's no reason why any of the developers couldn't produce these stateful sets themselves, but they shouldn't have to, because they don't care how Elasticsearch runs. They just want a big cluster with like 10 terabytes of storage, please. And then there's a team that manages Elasticsearch, and they've written all of the automation to do all that part, but they are also then on call for it. So the automation will also sometimes page people to say like, hey, this pod's in a broken state. If I give that to the user, they won't know how to fix it because they've never run Elasticsearch in their life, but you're the Elasticsearch team, can you go in and figure out what's broken with this Elasticsearch cluster? That kind of stuff. The Elasticsearch buddy handles backups. It does daily backups because the users weren't going to. It does all sorts of like automated machine tasks that the users shouldn't have to care about, basically. And to our downstream, they are able to just kind of declaratively say, I would like a big Elasticsearch cluster and what happens. We also have one for Memcache and Redis, and a different one that I touched on a little the last time I gave the presentation for stateful sets. Basically, we expose a service for each stateful set so that you can individually index into a particular host, essentially. And that's also written like this. You've got a thing, it watches stuff, and it produces new services with the stateful set scale, it puts them all to the right pods and all that kind of stuff. So these are automations that are kind of even higher level. They're just, we've invented a new kind of resource and then the means to manage it, basically. So those are the 4 examples I had. So I'm going to talk a little bit about a couple more things, and then we'll be done. A lot of them were alpha in 1.10, but they are beta in 1.11. Unless they're still alpha, but I think they're beta now. So one of them is, again, trying to make things more like the built-in resources. They support versioning now, so you can have multiple versions of your resources, and you can. So if someone produces a cluster version 1, you can receive that, but also support cluster version 2 at the same time and do like translations and back and forth and stuff. It supports validation, because previously I could put any fields I want in the cluster. I didn't actually tell Kubernetes what a cluster looks like. I just said there is one, you should expect it, and then give me back what they gave you. Which had the problem where someone would put garbage in, and the Kubernetes would be like, yep, you posted, I've got the data, we're all good here. And then in the background somewhere, some automation was freaking out because there were unexpected fields or whatever. So now you can actually put field validation into your Kubernetes resources, so it can say no specification. My cores value is an int, that you gave me a string or a map or something. Or you did not provide some value that I need to operate, that kind of stuff, so that when you actually push the custom resource in, it will say no. Custom columns. So currently, if I go back to this thing and I do cube get like tokens, I just have name age, but in 1.11, you can say like age, maybe I would want age and permissions or something like that. So I can just list my tokens, and it has a default set of columns that will print out to show me information. They have statuses. So again, similar to deployments or whatever, let's say I have a database provisioning custom resource. What I can do is, when I produce it, I can set a status on it that says, I am currently provisioning, and then when it is done being provisioned, I can say that I'm complete, or I can say that there was an error or something, and the Kubernetes tooling will kind of recognize that, whereas right now it's just kind of a free-for-all. I can also set scale, so that if I do like Kubernetes scale, number of replicas 10 or whatever, I can hook into that, so I can use the same scale command that I use on my Elasticsearch as I do on my deployments. And if I've got some web front end with a slider or something, I would probably magically work too. Wouldn't have to be. So those are the kinds of things that come in to make the custom resource definitions feel even more like the built-ins. What else have I got here? Next slide. Here we go. So then there are other kinds of extensions that I haven't used and I haven't talked about it at all here. So one of them is the aggregation layer, which came up a bit during the first talk. The aggregation layer, so the way that all these work is they say, here is a custom type of resource, I would like you to manage it for me, and just tell me when you have one, and like when it changes or something. The aggregation layer is kind of the opposite. It says, this is a path, people are going to make calls to it, don't handle it, just pass the calls to me and I'll do something. So in this case, you can still run it inside the Kubernetes cluster, but basically this is a different API rather than using the Kubernetes API to manage all these things. So it would work very similar. I would say Kubernetes get tokens or whatever, but rather than going to the Kubernetes server and asking it for all of the tokens it sees, it doesn't know anything about tokens. It just proxies the request straight through to this other API server and says, hey, someone was asking for tokens, you deal with it, and then they can return whatever the hell they want. So that's another way of doing it. There's pros and cons. Basically, the pros is that it's more flexible because in the end it's your own API that's getting hit with all these API calls. But on the flip side, you have to manage an API server yourself, right? You have to have a database where you store tokens and stuff like that. Whereas using the custom resource definitions, Kubernetes stores all the resources for you, and you can just ask them for it when you want them. But they're both options, and some things lend themselves better to one or the other. CoreOS has an operators framework, which they call the operators framework, that basically is for all of these kinds of things, like the CRDs and stuff, but it's just, it tries to get rid of some of the boilerplate and build some best practices in, so it will update your functions when there's a watch that that comes true or whatever, and they've done a lot of stuff to try and, again, to make a thing that's built to handle these kinds of operations. They've given you a whole toolkit of things that do this. They also have built into that like a deployment manager thing. So you run the deployment manager, and then you tell it when you want to run some custom operator. It will go down and fetch it. It will spin it up in its own namespace for you somewhere. But more importantly, it will also do like upgrades and stuff. So if you say you're running this Elasticsearch integration version 1 of yourself, not the CRD version, but like the code version, you can tell it like I'm going to run a new version now, and it'll do some sort of migration for you, or like with you, and it'll reparent all of the resources to this new deployment that's running instead of the old one, stuff like that. So that takes away some of the boilerplate and tedium. I mean, the Ruby stuff was actually pretty boilerplate free, to be honest. Helm exists. Yeah, I think that's mostly it. Oh, and then for legal reasons, I used some icons. You don't actually have to read any of that. That's just credit. That's the end of my talk on custom resources and automation. Do people have questions? Shopify? Or me? I believe Shopify is hiring, but yeah, we're hiring some stuff. And like, to be honest, like, so I talked a lot about all the cool buddies and stuff that we're running, but like, I mean, things aren't perfect either, right? Things have bugs, things are older than they should, things haven't been migrated to reverse Kubernetes. But like, yeah, we at some point the department that I'm part of decided that like in-cluster automation was a thing that we should work on, and so we built one. And I've been relatively happy with it. It's not hard.
How does the infrastructure team work with the end users who want to deploy Elasticsearch, for example? How does one go about teaching the infrastructure team to document and say this is how Elasticsearch should be requested by the end user?
So hang on, is your question more about the end user or more about the infrastructure team?
I guess it's two-edged sword.
Both? Okay.
Yeah. So I would like my developers to request an Elasticsearch cluster correctly.
Yeah.
How do they go about knowing how to request it correctly?
Yeah. So we are large enough as a department that we have like support and documentation people on the infrastructure team, and so they make sure that we do that. So we have like a kind of a catalog. We have a series of templates for like these custom resources, right? If you would like to do search, here is an example Elasticsearch document you can cut and paste into your own deployment templates, because basically we put all the templates in the users repositories, and then we have a tool that kind of deploys them all. And so yeah, we say like go put this in this folder and change these fields, and then you will get an Elasticsearch in this like in this environment variable, like a secret or whatever. Put this snippet into your workloads to connect to Elasticsearch, and your Elasticsearch URL will just be in this environment variable. We also have templates. When people generate a new service, they click the like, I would like a new service button. We say, would you like Elasticsearch with that? They say yes. And if they say yes, they get Elasticsearch kind of dumped for them into their first deploy. And if they don't, they don't. And then the documentation is there to like add it later if they decide that they want it later. So mostly it's the boring answer, which is that like we just do it. And we try, like we try to keep a focus, because we're not building these Elasticsearch automations so that no one can use them, right? We want people to use them because it's easier for us to support the thing we wrote our own automation for than to write the like janky deployment they cobbled together and it was awful. So we try to focus on making it so that they can use it by writing documentation or whatever, because that is easier for us in the long run than getting a page at 3 in the morning, because it's like, I don't know, they all can't talk to each other anymore. It's like, what the hell even is this? Yeah.
Piggybacking on the question, how self-service is what you guys have for the developer in terms of
Right.
process? So if I'm the developer and I want to spin up the search cluster, I would do that myself.
Yeah. So this, I probably can't show it. But yeah, if you, like, we have a web app where you can basically click new service, you tell it what GitHub repo it's pointed at, and then it asks you, like, do you want these things? And you click yes. And then it makes a pull request on their side with all of the like Elasticsearch, the identification, what else, like Bugsnag, all of those custom resources and stuff that I've talked about, some annotated fields. And then when they merge it and it deploys, our automations go pick up all those custom resources and spin up the Elasticsearch, spin up the tokens, spin up the whatever, hook it all up, the buckets or whatever. So it's actually pretty, like the Elasticsearch team doesn't know when a new Elasticsearch cluster gets spun up anymore. They find out when something's on fire,
right.
But like they don't touch anything when a new cluster spins up. It's all off, hands off. And like again, like backups and stuff all get handled by the automation as well.
So then how do you guys handle provisioning? We're on Google. So
for most of this stuff. So GKB handles provisioning. We have kind of a general cloud team that watches the usage levels and dials numbers up when needed. We have auto scaling on some clusters, but sometimes we don't trust it. But yeah, it's so that again, one of the cool things about how this is all kind of worked out for us is that we do actually have some pretty sharp separation between things. Like the search team doesn't spin up clusters. Like the app team doesn't provision Elasticsearch. The search team doesn't provision nodes, and the nodes team doesn't know about Elasticsearch or the user's apps, which has actually kind of been pretty nice. Question?
How do you make sure you don't need too many?
You don't. We just trust that hopefully everyone's okay.
What was the question?
How do you make sure you don't make too many? So is this like people spinning up superfluous clusters that they don't need, or like making sure that the automation doesn't freak out? Yeah. So with superfluous clusters, we have a different automation I forgot to talk about actually. Jeez. Well, it's good they were done with that.
All developers are responsible for these resources.
Huh?
All the developers are responsible for these resources.
Yeah.
It's not
So
something we're worried about.
we have a couple of things to answer that question. So one of them is whenever anyone's testing a new service, it has an expiry associated with it. And we have a different buddy that I forgot to talk about that basically just runs through and says like, hey, these namespaces are expired, and it deletes them. And all the resources get deleted, and that all kind of gets cleaned up, so that's kind of neat. People can obviously just click the graduate button, and then it moves up, so like, it's not perfect, but it's a nice low pass filter for like, I spun a thing up to try it once, I forgot about it, it kind of gets cleaned up on its own. The other thing is that nodes team, I said that they don't really know about Elasticsearch in the user's apps. That's only abstractly true. But they do have like a list of usage by namespace and things like that, and so they can say like, whoa, our financial output just went up like crazy. Who the hell is using 15 nodes? And they can look and say like, oh, it's that project. Yeah, they need it. We're like, who the hell? Like, you know, let's go find that team and tell them that they're being ridiculous. And so, kind of caught under that umbrella would be things like the Elasticsearch clusters, where if the Elasticsearch cluster was enormous, it would make that that particular namespace an obvious sore thumb, and then someone would go track them down. What happens in practice probably is that the nodes team would tell the Elasticsearch team, hey, Elasticsearch is taking $100 a day or a minute or whatever over in this cluster. You should fix that, and then they would be like, okay, maybe they would go find the downstream team and be like, guys, why do you need so much Elasticsearch? Maybe your queries are shit. I mean, probably. But yeah, so it's a little bit trust and a little bit monitoring. Trust and verify. Yeah. Other questions? Or should I answer your question?
Sure.
That's not 100% satisfying.
Given that it seems like you have a very complex system and several teams working together to make everything work, what would be your footprint that you would say for a specific team, this is how many people actively managing this sort of thing? Just to get a gauge of how complex things get.
Yeah. So the initial automation does add some complexity, but like once it's there, the usage kind of drops. So like the Elasticsearch team is like 3 people maybe, and most of what they focus on is like the 1 or 2 really big Elasticsearch clusters that power like our admin interface and stuff. The app clusters basically never, like the automation kind of handles it, right? Like when Elasticsearch crashes, Kubernetes restarts it because we're using stateful sets. I mean, that's kind of the other thing, right? Like the reason why I built the automation, the example that I did that uses deployments is because that's kind of a feature of Kubernetes is that you only have to cover that last little bit that Kubernetes did, right? It doesn't know how to run an Elasticsearch you can just build a stateful set or a deployment, and then it manages the 90% of the actual thing, right? When the cluster dies, the Kubernetes will restart it. When you want to scale up, you mostly just tell Kubernetes, I would like to scale up, please. When you want to do a rollout, you mostly just set some values and it'll do the rollout for you. So all that kind of stuff is handled for us. The only times when the Elasticsearch team gets paged is sometimes Kubernetes will do something weird. And like some pods will get stuck in a broken state. And the team doesn't know enough about Elasticsearch or even Kubernetes necessarily to fix it. So they just say like, our search is struggling and we do it. And we're like, oh, I can see why. Let me just Kubernetes some stuff. Sometimes things like backups may be broken, and we go in to figure out like, oh, the bucket got screwed up or something. And sometimes things will legitimately go down because there was a bunch of nodes failed all of a sudden because of a kernel panic or something. And so now the actual Elasticsearch business logic stuff is in a bad state, and the Elasticsearch team has to go in and like fix it. Using Elasticsearch knowledge, but like those things are pretty rare.
Yeah, that would be the exception.
Yeah, and like I don't think that's happened in the past couple of weeks. Like the Elasticsearch team at this point is basically focusing on like forward-looking either more automation to fix either those problems or adding features like like the backups weren't there in the original version, but it's like all right, since nothing's on fire this week, like we're gonna add backups to everybody. That's the kind of pattern that we wanted to get into is once you fix all the stuff that makes the pager go off every couple hours, you can now spend all that time like doing more stuff to make you even less important to the whole operation and everything.
Or make the pager go off.
Huh?
Or make the pager go off more.
Yeah, more differently. New exciting exceptions.
Yeah.
So the Kafka team is like 3 people. That's just like Kafka for the whole company. And again, most of the time we are working on other stuff, like API patterns or libraries to help particular use cases. Like I can't think of the last time that I got paged for something. I'm on the Kafka team anyway. I can't think of the last time I got paged where I had to actually do something. Like sometimes people will page me and they'll be like, oh, we're seeing like 2-minute delays. It's like, oh, I look and I'm like, oh yeah, one of the brokers got restarted. It's on the way back up now. Just wait a minute. It's been a while since there was a thing that I actually had to do that was related to operations. Most of the stuff I do now is like again advocacy and library development. Other teams aren't as far along, but they're all kind of getting there. And so yeah, like I said, like when we deploy a new database or when we provision a new database, the data source team doesn't really touch it unless something explodes, which it rarely does. The team kind of just requests their own stuff. And these are all things that you can always do, right? Like again, Kubernetes, it doesn't solve any problems that previously were literally unsolvable. It's just what we like about it is that it's all kind of one uniform interface. And I can deploy my workloads and my databases and my DNS and my abstract concept of a search cluster all in one folder. And then all the magic happens through experts that I'm not. Yeah?
So you have like a DevOps group or team that's overseeing this process?
Yeah. We call it production engineering, but yeah, it's a mix of ops and development that isn't quite what most people think of as DevOps. It's more ops than DevOps, but basically, yeah. Ops write code to replace the ops work. that's kind of, yeah.
So is that like a cross-functional group? Because you talked a lot about separate groups, but is there an actual defined group that oversees all the separate groups and services? Is it unified direction and development?
Not fully. So there is a real department that has like an org tree and everything. But not everyone in that department works on this kind of thing, right? Some of them work on like Akamai, and like that's not really related to any of this. Like, they're doing their own thing. And like there was never really a declaration that everyone must do automation and extension APIs. It was kind of like roughly encouraged, and different teams kind of picked it up there is a department that's focused on keeping the lights on. And this is how we do that most of the time these days.
So you mentioned the API master, that's just like a raw master, like boxing to.
As far as I know, I haven't used the aggregation API myself, to be honest. I'm vaguely aware that it's there. Because most of the things that we wanted to do are the kind of things where we are fully comfortable with Kubernetes managing all the resources and we'll just respond to them when they show up. But my understanding is that it's approximately a pass-through. Has anyone had experience with the aggregation API? In that case, take my word as law unless you read differently. But yeah, I think it's approximately a raw pass-through. And then I assume that there is an expectation that you will accept requests in a format similar to the ones Kubernetes accepts, and you will return responses in a format similar to the one Kubernetes returns. There's no necessary reason why you have to, probably, but like I imagine most of the API clients are going to expect it to look Kubernetes-like, right? You're not just going to hit like an XML API all out of nowhere, but
That's exactly what I was thinking.
how can I get more soap into this? But yeah.
How long have you been working with Kubernetes?
A year.
So you started a year ago from zero and built all this?
Roughly. Like maybe a year and a half. Maybe a year and a half. Yeah. And like I said, different teams kind of picked up at different times. It's been kind of like an ongoing thing. Like we didn't start with all of the automations we had here at day one, obviously. And like different teams have come on at different times and added their own little bits of automation. So we've been running it in production for basically a year, and we started about a year and a half ago, basically. Now, we started on GKE, which solved a lot of those early problems, like how do I get it to run on nodes. We had a team at some point that was working on how to get it to run on nodes, but we eventually shelved it to focus on other areas. We might bring it back up again later. But for now, like GKE helped us to get going faster. So we could basically right from day one, we could click the button and then start worrying about how to use this thing rather than how to run it. But except for that one team. But yeah, we pushed pretty hard on it. And so again, like the Elasticsearch team is like 4 people, and the Kafka team is like 3 people, but like the department's like 100 or so. Like there's was more than just 10 people working on this.
Yeah, I was just going to say, these are something that Shopify is probably one of the largest GKE customers.
Yeah, for sure.
So it's a big team. It takes a lot of engineering effort, and they do cool things with it.
Yeah.
This is one of the things that it takes, a group of people who can build.
I wasn't really sold on all this.
I think it's really cool to hear the story of what's extensible. It's something that a lot of people don't talk about. They talk about what's out of the box. And
Yeah.
if it's not out of the box, then you can't do it. But the API is super extensible. So you
Yeah.
can do a lot of it, which is cool.
And that's the direction that Kubernetes, I think, is moving, right? They gave a couple out of the box important pieces, but then like first with third-party resources, which were like strongly second class, and then like with custom resource definitions, and now in 111, so all the extra features and stuff. Like at this point, they're basically just kind of opening it up and saying, okay, this is what we built. We built these atoms. Now you do something with it, like go build your own stuff. And the other thing is like with things like Helm, which I basically didn't touch on at all. That was my page
We all have to go.
Oh, what's it? Yeah, sure. Anyway, one of the things that's what was I gonna say? So Helm is a system for deploying stuff on Kubernetes. I've never touched it, but I've looked at the docs a little bit. So one of the other kind of neat things is with these kinds of deployments, because they just are things that run in Kubernetes and they publish custom resource definitions and stuff, there's no particular reason why you can't find an Elasticsearch Helm chart that publishes the same kind of search object that we define in our automation that manages it the same way our automation does. So as the community kind of matures, you might be in the situation where you can just say, oh, I've never been able to run search before because I've never put the effort into it. So I can just do Helm, go get me my Elasticsearch controller. It pulls it down, it runs it, it installs the charts and all the automation, and now I can just push my own search clusters and it'll, the automation will provision them. And obviously, no one's there to back me up if it catches on fire, but that was already going to be true, but it saved me a lot of work in the meantime. So that's the kind of direction that it could be going. I'm sure it is going, but I haven't looked. Because it's all running its own bootstraps, so you can extend it 10 times, but yeah.
Helm and CRDs are not mutually exclusive either.
Sorry?
Helm and CRDs are not mutually exclusive either.
Sure.
You think of Helm more as provisioning. So
For sure.
Templating for your deployment. So as opposed to say, okay, I implemented these configurations. Your Helm chart has the template for those versions. It has a couple of nice hooks like, okay, you can do a post deployment. Once I deploy this, run something else. And then the dependencies on other Helm charts. So you have, okay, I create a Helm chart for your application, and that one has a dependency on research chart. But there's good things that create custom search applications that have their own functions.
Yeah, sorry, that was what I meant to imply. Helm predates all of the custom resource stuff. It's just a way of getting stuff to run, but since a running thing can do this, you could install such an integration using Helm and get a bunch of stuff for free. That's what I meant to imply.
We use Prometheus.
Sorry?
We use Prometheus.
Yeah.
And in our charts, we throw in a service monitor series, something like that. So it's
Right.
seems to be.
For you guys over here, you're saying that they use Prometheus, and the chart in question produces service monitor CRDs. So at least one chart's out there is doing the thing I just suppose probably is a thing. Cool. Anything else before everyone goes home?
You said you had CRDs for databases.
Yeah.
So are you running your databases in Kubernetes proper, or are they sort of external and CRDs are just sort of moving everything back?
Yeah, we are not running the databases in Kubernetes currently. We investigated it, and the data stores team, which is more paranoid than the rest of us for pretty obvious reasons, didn't feel comfortable. So we are running databases on nodes, like on VMs that are managed separately. The database resource is just a window into that node.
But will provision a node and set up a database or
Yeah, so it goes out, it provisions some stuff, and then it comes back and produces a secret into your namespace that's got all the connection credentials. So that your workloads can just say database URL is right here, and it just does connect. But the database themselves don't run in Kubernetes currently. I mean, they could modularly, they just don't.
No, it was more interesting.
Yeah. Okay, anything else this time before everyone can go home?
Thanks for everything.
Thank you.
Yeah.